All right. So I'm standing in between you and the end of the day. I don't know if that's cheers for the end of the day or the cheers that I'm back up here and you have to listen to me ramble. So yeah, let's go ahead and get started here. This might take 10 minutes, depends on how much people want to actually participate. It might take an hour. That's the fun of this one. So this BoF is one that Jamal had an idea about a few years ago and came to me and said, hey, what do you think? Let's put this together, and thought it was a great idea. So if you haven't been to a Netdev in the last 2 years and don't know what this actually is, that picture looks pretty wild. I think Jamal broke it. This is what I get for actually making slides. So, so I really like the idea of this BoF. This is meant to be, we all get together from all over the world. All of us have various ways of approaching things in our day-to-day jobs or our hobbies. And why wouldn't we want to share something that is kind of useful to you and maybe give like that aha moment to someone else? If like something very, very simple. 2 years ago, we had some people sharing like how they were measuring timing when they were doing performance analysis. John Osterhout did that, and I thought that was pretty cool. And then one of the next talks was how to interface with back-end APIs of ChatGPT in order to avoid having to pay larger costs using the UI. So it's kind of cool stuff like that. So this is a pretty free-form BoF. It's getting freer and freer here by the minute. No, it's okay. See, if I had my Linux box here, this wouldn't be a problem. Anyway, so this really is pretty free form. If you've got something that you'd like to share, you don't have to have a slide. You can come up for a minute, you can come up for 5 minutes, something that you find interesting, something that you find might be helpful for someone else to not fall into a pitfall or like a hole. So I'll actually share something this year because I haven't the last 2 years. Got to throw a couple things in to wake everyone up at the end of the day. So, how many of you in here write out-of-tree modules in the kernel? Yeah, I know you guys do. Or out-of-tree drivers. And how many of you who do that live in a distro-driven world that you actually have to deal with, like distro kernels like a canonical kernel or a Red Hat kernel, SUSE, and not use like vanilla upstream kernels, maybe not in development, but actually stuff that you have to deploy. Like, don't be shy, right? So I like to call this the distro kernel purgatory because, ABI never changes, right? And so I call bull cookies on that. The ABI does change sort of, right? So even within, like, say, like, a rel 8, between 8.6 or 8.8, or even within 8.8, when they rebase a kernel, sometimes things get a little bit hairy if you're writing out-of-tree drivers. And this is a nod to my fellow coworkers from Jump who have gone through this pain very recently. Of the Ethtool Yeah, you're laughing because I told you I was going to put this in here. Moving away from ioctls to Netlink, right? And this has been something that's been in the works now for what, 10, 12 years, maybe more. And there's these handy macros that get stuck into the kernel. And well, at some point, sometimes a backport and a new rebased kernel comes out, and this doesn't actually work as intended, and then your driver breaks, and then you get very sad. So I don't have solutions for that, other than just like using upstream vanilla kernels, which that won't really help you in many cases. But what I did want to share, and many of you may already know that this exists, many of you may not, and that's the whole beauty of this BoF. How many of you have actually used Elixir or Elixir? Right? So you can go, indexes the Linux kernel, go in there. Well, what if I told you you can run your own and actually index a distro kernel? And you can find these things so that when you actually say, oh crap, I ran into this backport mess, I'm running this kernel now. Well, what changed? And I can go look at this file on Elixir and put them right next to each other instead of going and ripping apart a source RPM and using VI and then ripping your hair out. So what's really handy is you get a clone of a Linux kernel source tree, and you go get one of those source RPMs from your favorite distro, you rip it apart, and usually there's a giant patch that's sitting next to the tarball of the vanilla kernel that it's based on, and go apply it to your Linux kernel tree, and then tag it with whatever that version of the distro kernel it is. And the infinitely small text way down at the bottom, there is a tag down there that is the EL88 kernel. Really, really handy if you're writing out of tree drivers and you're trying to figure out how to backport something or forward port something. And it's a GitHub thing. You can go grab it. It's a self-contained Docker thing. And you just point it at tags and tell it to reindex and poof, there you go. So super simple. Probably everyone in the room knew about it, right? Okay, well, there you go. All right, who's next? Johannes, or are you just going to poke holes in this now?
No, I was just going to ask a question. Does anyone do code coverage analysis on their drivers, things like that? Because I wrote at some point a plugin for Elixir to show your code coverage in this interface, basically.
I think you should put a slide together and then send it to me, and we'll put it into this. Or you can submit a patch to the Elixir project. I don't actually run it in production
right now because we never actually productized it, but I have a kind of a proof of concept to put code coverage in there, and it's some layout of how the URLs work and all that.
I think
we'll probably put it in a. I think we used to put it into a notes branch, so you would get the elcov file or whatever into a notes branch and then parse it out at runtime to show the code coverage in Elixir. It's kind of useful when we had it, but right now we don't have it running.
Nice. Okay, so this is the point where if anyone has something that they want to share, this is a safe space. No one's going to make fun of you. Jamal promised that he was actually going to come up and, what's that? Yeah, so Shannon? Yeah, Shannon's got something that he was going to share with us. Like I said, this could take an hour, could take 10 minutes. It's really how brave do you want to be?
Ooh, there we go. Slideshow. You're short. You just noticed that? I've known PJ a long time. Okay, so that's the wrong page. Let's go back. Okay, so this is a quick little thing. A couple months ago, I was working on a little bit of Etltool API I needed to add. I wanted to get more info out of the EEPROM modules from one of our NICs. It's a let's add get EEPROM by page, because we were printing out stuff and it was garbage. It's like, why are we getting garbage out of this? So let's add this. Let's make this work. My code looks right. Etltool code looks right. Why am I getting garbage printed out when I'm trying to print extra pages about the module? Well, what do I look at? Well, how's the data getting passed? It's Netlink. Not one of my favorite things to look at, but okay, let's go dig into that. So how do we dig into that? Go ask the web. What are we going to do? Oh, PyRoute 2. It decodes things. Never tried it. Go and dig it up. Find some instructions. Create a little network device that sucks up these packets. Very handy little commands there to look at. Use TCP dump to go grab the packets and store them away, and then use PyRoute 2 to decode them and give you a nice little write-up of what they're doing. At least that's the expectation. Unfortunately, A, I was in a hurry, so I didn't want to dig real deep. B, I hate digging deeply into Python at all. But there's some mess of libraries here that had a problem, and I did a bunch of futzing around with the data, and it just didn't get anywhere. So, well, what do I do now? Oh, wait, I have a PCAP file. What do you do with a PCAP file? You put it in Wireshark. And hey, you go find the packet, and you look, the working case on some other company's NIC has all this big chunk of data coming up, and mine didn't, which gave me a really big hint on what's going on. Anyone know what the problem was? Turns out the get EEPROM by page doesn't follow the standard pattern of all the other Ethtool callbacks. I was returning 0 on success, like you're supposed to, right? No. I did not read the documentation correctly to find out that this interface, this API works a little differently. Once I figured out I need to return actually the number of bytes, oh, it works very nicely. So, Ethtool didn't see an error, Ethtool saw 0. But the Netlink side of Ethtool didn't notice that there was no data. It just noticed there was no error. And so it decided to go print data that was in an uninitialized buffer, which I thought was a little sad. But anyway, so what did we learn out of that? A couple of things. Wireshark is wonderful, but then we all knew that, right? Read the comments about your interface, and then go read it again. And then go read it again, because you probably missed that last 4 words that says, returns the number of bytes. And then when you're writing interfaces, please be predictable, especially when you got a long list of interfaces or APIs that return 0 when they're happy. Don't add one that returns something other than 0 when it's happy. Anyway, that's me.
Awesome.
Oh, and use stget. It's wonderful.
I'll remake this short again here. Thank you, Shannon. Who else? Who else? Who's next? Okay, come on up.
I have a quick comment. Ethtool --debug prints the Netlink messages.
Yeah, hello. I'm Eugene Crosser. I do not have slides. I just will say a few words that actually latch somewhat to the previous speech about Pyrote. So I want to talk about user space. And of course, still the kernel, it's all kernel's fault. Because kernel uses this Netlink, right? And you do anything network related, configuration and query over Netlink. And of course, you do all this like glue code stuff, configuring, putting things together in Python, of course. And then you, at some point, want to like dump all roads in the kernel. And of course, you do it with Pyrote too. But there are 60,000 roads in the kernel. And you spend next 5 seconds of 100% CPU time parsing these Netlink messages. So what we did is kind of perpendicular approach to Pyrote. We are parsing Netlink messages in pure Python, but not take message and convert it in a Python object. Instead, we have something that can be called a parser combinator library. So you have some Python classes, and you construct from them what elements of the Netlink message you are actually interested in. So you just point out, take this value from this NLA, and if this value is like this, then examine next NLA. And it is much more awkward than just throw a whole message and get result, but we have very significantly better performance. So in case anyone have this problem with speed of parsing of Netlink messages, yeah, maybe we have a solution for you. I have some link on paper sheets, so come to me if you're interested. That's all.
Great.
Thanks.
Thank you. Yeah, come on up. Yeah, goodness.
Right. Hello there. And I'll start with the quiz. So for 3 days of this conference, on how many of those days you have heard VXLAN being mentioned, either in presentations or discussions? Well, you actually have 4 options for an answer, 0, 1, 2, or 3. Any takers? Well, right, so I heard a gentleman from the back saying 3, right? That's correct, and you get a virtual prize for that. However, I'm not that happy about this. First thing, this is not a new rant from my side, and it's mostly from the operational side of the house, as I happen to run many of the things that you design here and implement. This has been presented to the operators community quite a while ago on various occasions, and for me it was a refresher here that VXLAN is still alive. So looking back into the history, back in around 2011 timeframe, Dinesh Dutt was working on, well, on some specific product that he wanted to conquer the world with, and he designed a very simple layer 2 over layer 3 tunneling mechanism. Well, basically take the intact frame, carry it over with the minimalistic, say, additional functionality, and be able to receive that on the other side. This appeared to be a successful accident. This got published as an individual stream document in IETF, and it took over the world. So then whoever wanted to tunnel layer 2 over layer 3, they were happily using and abusing that in various, sometimes very creative ways. There are a few problematic aspects with VXLAN as a capsulator. Suppose you want to carry more than one payload type over the tunnel between the two endpoints, and in fact you cannot do that. Well, of course, on the source side you can inject two different payload types. The problem is that the receiver side won't be happy if you did that. There is no way to differentiate one payload type from the other. And scenarios where you would want to do that are plenty, starting from broadband aggregation, running service level liners. Like, for example, how you would run a BFD session which validates that on a service level you have the connectivity over the tunnel, right? So you want to kind of know that there is actually that the tunnel itself is up and operational. You can inject that on the source side. On the receiver side, you cannot differentiate that incoming OEM and BFD, in this case, traffic from the actual payload. This would require for the application to be aware of that, and that's basically intrusive. Then everything that goes into the tunnel at one end is treated as the client payload. If you want to do any visibility or in general OEM operations on the tunnel, imagine you have quite a few possible paths between the tunnel endpoints. Well, think of a multi-stage flow fabric. So you can easily talk about hundreds of possible paths between any pair of endpoints. How do you tell which particular node or which particular link is doing something bad? Basically, elementary troubleshooting, how you trace such a topology, how you validate the end-to-end delay, how you ensure that you are connected to the endpoint that you are supposed to do. You actually cannot do that. And this can be solved if you ran OEM payload indicated via a different protocol identifier, but we don't have that, sadly, so there's no option. And the third one, which would solve both of those problems, it's the lack of extensibility. VXLAN initially was designed as a simple protocol, and maybe it was a bit too simple. Since all of the possible values that might be reused for extensibility, there's no single registry that would allocate the values there. Therefore, the industry kind of moved into the uncoordinated mode where there were code point hijacks, and in general, there's no versioning, there's no kind of one central entity that would kind of coordinate this. There's no IANA registry for VXLAN, any of the options or bit fields. Therefore, this protocol is simply not extensible. The other thing is that it's a little bit too simple. Well, basically, we have 8 octets for the header, and while only a few bits in that header are used, there's basically no forward-looking and extensibility mechanism that you might practically use. And this is not a new problem. This has been acknowledged quite early from design stages of the VXLAN, and that was intentionally done so. A few years later, there was a big war on IETF on which encapsulation will rule the world, and there were quite a few of them. And many of them are surviving to this day, and they are deployed. The official, kind of call it a blessing, well, there's no such thing as protocol police. IETF cannot come and tell you that you must use this, otherwise there will be consequences. But out of the choice of the multiple possible capsulators, which basically do the same thing, The official recommendation from IETF is Geneve, which is basically both the acronym and the name, Generic Network Virtualization Encapsulation, which tries to address all of the three above-mentioned problems in a rather, say, structured and extensible way. You have a registry. That means if you implement your private implementation, you can get code points allocated and there will be no conflicts with others. Well, basically, it's a first come, first served type of a mechanism where you get a code point allocated, you do what you want with that, and if you want to have either interoperate with others or operate in an environment that are multiple implementations supporting different functionality without a conflict, you certainly can do that. There's finally a mechanism to indicate the payload. There's finally a mechanism to indicate that the particular frame is not just a client payload, but an OEM one, which is meant for basically maintainability of the tunnel itself. There's a mechanism to alert the transit nodes that this particular payload is not, this particular message is not a payload, but an actual control message, and some action needs to be taken. So if you are thinking about a tunnel level trace route over, say, extremely meshed fabrics, you can easily do that. So in summary, Geneve is just like VXLAN, does the same plus much more and in a way better. You should use that. And this is a slide taken verbatim from 2018. This was the view of the industry at that time. The component vendors were seriously considering that. Now today, everyone supports, well, any credible vendor supports that. Systems, again, any credible router supports that. It's unquestioned. From the perspective of what you can use that from operations point of view, the standard, say, IP OEM, BFD, MPLS OEM, LSP, LSP ping trace, and general associated channel mechanisms. Ethernet CFM, Y1731, all of that is supported. And you can just use that. So please, if you are designing something new, VXLAN has served the industry quite well, but it's time to retire. It doesn't mean that you need to basically surge it out and replace with something, but if you are designing a new system, please don't use it anymore. That's it. Thank you. Questions, comments? Rotten Tomatoes? No? Well, thank you.
Hi, I'm remote. Can you hear?
Yes.
Oh, hi. So I have a sort of related question. Me and a couple other folks who are in the room are working on an updated version of ESP. And in our header, we have TLV options. And one of the feedbacks that we get is from hardware vendors who say, oh, that's too hard to support that. But I'm seeing here that you're saying that hardware vendors are supporting the TLV in this protocol then. They haven't given you pushback?
So just for my clarification, by ESP, you mean IPsec ESP, right?
That's correct. But
okay.
The main question is about hardware processing of TLVs in headers.
Right. So everything can be implemented. The question is at what cost? The fact that something is termed as a TLV doesn't mean that the structure is really free-form. The way, and that, yes, that was a large amount of discussions going on from a standardization point of view. What flexibility is reasonably enough or should be enough from a functionality point of view with regards to the size of the fields, the granularity of the fields, and at what point in, say, a header it is possible to extract something or it would be too expensive. So if we are looking from a practical point of view of parsing variable length fields from a hardware perspective, it's not that expensive to extract something. What is really expensive, basically you're limited by the memory and the bus bandwidths and how you get that data which you are operating on. Therefore, what Geneve does and this was agreement between operators and the hardware vendors community, there's a granularity of TLV options in a sense in increments of 4 octets. And your header may start only at the increments of those 4 octets, and some fields, some bits, basically, they are in a predefined location. Therefore, if you want to do a quick pass over the, say, semi-arbitrary large headers, you only need to look into certain fixed locations. If you find something there of interest, then you need to take the slower path and analyze that in more detail. So generally, it's certainly doable. The question is how deep you need to go. Geneve allows up to 256 bytes of the header size. And then at what cost? Basically, you can look into any arbitrary header. The question is how many cycles you will spend for that. It's basically it's a product design. The fact that the protocol allows up to 256, it doesn't necessarily mean that each and every vendor will implement that. You might be restricted.
Yeah, so I noticed in the Geneve header, there's a total op length. We did that too, so that the hardware vendors could, at minimum, all they have to do is grab the top length and skip the whole section.
Yes, and there's another important aspect. There is what is called a critical bit, and that the idea is that if you want to parse particular option which doesn't go at some fixed location, you mark the critical bit which is copied into the initial Geneve header. Therefore, any transit node which receives at the first basically 4 octets critical bit indicated as set means that it needs to go deeper and look into all the option space, trying to find that critical option which needs to be parsed in depth. So this is another optimization.
Yeah. Okay. Yeah, it's just it's a good to have the feedback, because my feeling is that IPv6 also has option TLVs, and so I feel like it's kind of a dated pushback, right, to say that it's too hard to handle TLVs at all in hardware. So this is just more data for that. So thanks.
Right. Well, now as you mentioned IPv6. Well, that's my favorite trend. The difference between IPv6 option headers is that they don't have as much of a restrictions as Geneve here in this case. Right. Basically, the length of option headers depends on the actual option. There's no such kind of a restriction that it must be the multiple in granular well, there are, but not as strict as in Geneve. Therefore, you need to do much more sequential parsing if you want to really parse all the IPv6 header options. And that is one of the reasons why hardware people don't necessarily like IPv6 that much, or they kind of limit of what can practically be done. You certainly can do it. The question is at what cost?
Yeah, I mean, I don't think we're planning on requiring hardware offload to look at any of the data inside the optional space. They just have to skip it. So it's just one look and one addition. Yeah. Thanks.
All right, thank you. Any other comments? I think I'll leave the stage for you then. Thanks.
Who else still wants to be brave? I have the email that Jamal did say that he promised he was going to get up here.
Okay, I have nothing to show, really. But I was going to volunteer Victor, but he chickened out on me. Somebody corrected that Ethtool -D. I can't remember. There's somebody at the back said it does what Shannon was trying to do. It could have helped. I don't know who said that. There's a debugger option which may have solved Shannon's problem. Okay, so the Ethtool -D debug. I was just going to say, stress has been doing Netlink for years, right? You can just run stress. And
well, I was also going to mention, when reading the interface comments, you also should check the length of the buffer that Netlink gives you in Ethtool when you're about to fill out your EEPROM data, because if you don't, then you can corrupt memory. At least I've heard that from someone else.
Should I start volunteering people, or that's... Anybody who's hiding from you, that's the person you bring up there.
No, there's no one back there.
Okay.
Oh, wait. Oh, we have a taker.
All right. Woohoo!
Thank you. Okay. No, I don't need sound, thank you. How many of you used Virtme-ng or... Okay, many hands, that's great. But I think it's worth to mention it. There was a tool originally written by Andy Lutomirski, it's called Virtme, but he pretty much abandoned this project, and it's forked by Andrea Ricci. He is now working at NVIDIA. What it does, it's basically, if you don't give any parameters, just run the command Virtme-ng or VNG, it virtualizes your current rootfs in it's a read-only, or it can read-write, but it makes an overlay FS, so you cannot corrupt anything on your real host. You see the rootfs in a VM with a kernel, and it can do lots of interesting stuff. It can build you a minimal kernel if you wish, what you can try out things and play with. It can download kernels from the Ubuntu repo and run it. It can emulate NUMA topologies, and you can run it in debug mode. I will show you that in a small demo. And in debug mode, you can use the Dragon, what was presented here as well, and you can debug stuff, and you can dump the core and use Dragon on it. And there is an interesting stuff. If you want to debug NVIDIA drivers or NVIDIA VMs, it can support VFIO bypass, so you can use your NVIDIA card in the VM. But what is interesting, it's still developed, it's still updated. As you see, the latest commit happened 1 hour ago. So there are lots of tools scattering around the internet which do similar stuff, but this one is actually developed and maintained, and that's what the main value is. And I just show you a small demo. Right now, I use a Debian testing on my machine, and after I install the debug package, I literally have to use just 2 commands, like starting the VM, and when it started, here I have a prompt. This is the rootfs. I can delete everything. It's remaining on the root. Right now I'm in a VM. And on a separate terminal on my host, I just run VNG-R. VNG-R tells Virtme run the currently running kernel. And with GDB, it can automatically attach on your VM, and you can do stuff like basic stuff. So you can know if you ping, it will break, and you can do single stepping and anything you wish. And so it saves you lots of time with the setup of QEMU, rootfs, and things like that. And right now I don't have the kernel sources installed, but if I install that with apt, I will see the functions as well. Right now, here it's only show the assembly because I don't have the sources right now. So that's all. Thank you.
Very wearily scanning the room. Everyone's eyes are down. Don't make eye contact. All right, well, I think that's enough torture for this. What's that? Oh, yeah, so I did have to, I promised my daughter, she'll almost be 10, and that's very important. She's not 9, she's almost 10. And she picked out this this shirt. I store my dad jokes in a database. And I told her I would wear it for one of my talks, so now she'll have to watch the video and watch a bunch of nerd stuff happen and fall asleep.
By the way, giving a shout out to Virtme-ng, the ng version of this. You familiar with it? Virtme-ng. Yeah. Is that the one you showed? Okay, never mind.
Sorry, what was the question? Sorry.
No, I was wondering, because you showed, are you familiar with the -ng version of this?
-ng? No.
Virtme-ng. Virtme-ng.
Yeah, that was what he had up here.
Okay, never mind. I need to wake up there.
All right, well, thank you, everyone, for participating and dealing with all of this. But yeah, we'll do it again next year. Thanks.